want to do is show you how, what I find an easier way of working out the neutral in a three-phase load that's not balanced, okay? So you're going to need some stationery. So you're going to need a ruler and a protractor, a pen and a piece of paper. So add this to your favourites if you're not at the level 3 stage for science yet, or if you are, just give it a practice and see how you go, okay? So, what we different phases. You've got 120 amps, 80 amps, and 70 amps. Now, what I'm trying to work out is that neutral current, okay? To make it, and I know it doesn't look perfect, but say there's 120 degrees between each of those. Now, the simplest way of doing this, the most pain-free way of doing this is, you're going to use a scale. So 120 amps, you're going to draw as 12 centimetres, okay? Now this is a bit I'm not very neat at, but just try as much as you can to get it exactly to 12. Okay. Now this bit might be patronising if you've used a protractor recently, but if you haven't, and which let's face it, most of us haven't used one since school or even then. So the 60 degrees is what I'm going to find in that equilateral triangle, and it's going to look a lot like the delta. So when you've got a balanced load, okay, but we're going to fill it in slightly differently. So I take the centre point of my protractor and I put it to the end point of my 120 amps. Label, 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 okay? It makes life a lot easier. So put it to the centre, and then line it up so that that purple line that I've just drawn disappears. And now you get to that 60 and just draw a little sort of notch, okay? So that you know that you've got your 60-degree angle there. Now I'm going to choose to do 80 amps, okay? So the 80 amps, I put the 8 there, and then angle it a bit, and just make sure that that 8 is on the end. And can you see how the ruler then cuts through that line there? And I go all the way to 0, okay? And that angle there is 60 degrees, and that length is my 80 amps. Okay, so I've got a little bit of that triangle drawn. Now I'm just going to move it slightly, and this is where it's a bit back to front. I'm going to take it to the centre point again, to the end, and I'm going to make that purple line disappear. There we are, lovely, it's along there. And can you see I've got 120 and 60, so I can now draw my little line there. And then I'm going to take the ruler, pop the 7 to that corner, and then wiggle, wiggle, wiggle. This is a bit I don't get very, I might stick my tongue out when I'm doing this, but you don't need to see that. So I can see it's just touching on the 7 and just touching there, and I do it to the 0. Okay, and I'm going to put in that that is 60 degrees and that that is 70 amps. Okay, so now this is the bit where I can now measure my neutral. So this bit here is the imbalance. It's not going to be a perfect triangle, it's going to be imbalanced. And I can literally just draw a straight line from that edge to that one. And I think that measures about, oops, sorry, try and be as neat as possible, measures about 4.5 centimetres. Okay, so if you can see that's 4.5 centimetres, and I'm going to call that then 45 amps equals the neutral. I personally think that this is a lot easier to do than, you know that great big long equation that you could do? I just think that this is more suitable for people like electricians, or hands-on people. Potentially, if you're in an exam condition and this question might come up, you might not be able to remember all the other equations and this equation. So this is a nice, easy, straightforward way. And if it did come up in the exam, you'd probably have enough space to draw it. I'm not saying it will come up because there's more than one exam for your science paper, but it is in your science syllabus, so it's worth learning and understanding. Okay, thanks.